From the Youth Science Council, this is Good Question, a podcast about science in the UAE. I'm your host, Sarah Shirbaji. Today we're joined by Omran Sharaf, Project Director of the United Arab Emirates' first mission to Mars, also known as Hope Probe. Omran gives us a really thorough timeline of the Emirates Mars Mission and tells us how relevant Mars is to our planet, Earth. All right, welcome to the show, Omran.
Thank you for having me here.
All right, let's start by describing your background leading to, up to your involvement in the UAE mission to Mars.
So I was born and raised in Dubai. I graduated from Rashid School for boys in 2001. I went and pursued my degree in Bachelor of Science in Electrical Engineering at the University of Virginia. His Highness Sheikh Mohammed bin Rashid sent me basically a scholarship from him to study over there. And I graduated with a degree, electrical engineering, in 2005. And right after that, I actually, once I came back here to Dubai, I was still trying to find what job opportunities are there and where to basically go, whether to go and continue my studies or should I try to work and then get a higher degree, either master's or something else. The funny thing is, once I reached Dubai, this opportunity came up in which, because I was sponsored by His Highness, so they kept a record of the people who were studying abroad, who His Highness sent to get degrees in different areas. And basically, they told me that His Highness is trying to set up a new organization and launch a new project. An organization that's related to science and technology. And the reason why Dubai government is looking into this is because there's been significant development in different sectors when it comes to financial sector, real estate, and so on. But if you're talking about a sustainable, knowledge-based economy, sustainable development within Dubai and within the UAE, you need to build a science technology sector here.
Yeah.
You need to have some kind of activities locally, especially that our economy depends heavily on technologies, and most of those technologies are imported. So His Highness's vision was basically, let's think about a project which will use as a catalyst to build capacity, national capacity, in this field. At that time, a lot of the people who were studying engineering and sciences, they worked in their fields, but at a very high level. They never went deep into technical developments. There are a few people who did it, but it was more of a personal commitments in which they did it on their own. So His Highness wanted to create job opportunities for engineers and scientists who want to go into this field of R&D. He wanted to create and develop the culture of research and development in UAE through that initiative. Especially that, as you know, UAE and Dubai, we have the culture of merchants. It's always been a trade hub in the region. If you have R&D that's related to science technology combined with that, then there's a lot of good impact they can get out of it. So basically, that's why one of the first initiatives that we considered was a space program. Why a space program? Is because to build a space mission, you need to have an electrical engineer, you need to have a mechanical engineer, you need to have a software engineer, you need to have a scientist, you need to have people from different technical and scientific backgrounds working together, developing a mission. And that's one unique thing that the space program got. And also, on top of that, the challenge to put a spacecraft in space. So it's a big, ambitious challenge, something related even to the national pride. At the same time, it inspires youth. So a space mission made sense. I was part of the team who was working on this initiative, and His Highness announced the establishment of the Emirates Institution for Advanced Science and Technology in 2006, and the first project was assigned to it was the DubaiSat-1 project. Of course, now the institute has been renamed to the Mohammed bin Rashid Space Center, and that happened in 2015, because the space program is the biggest program we have within our organization, and also because UAE government looks at the space program as a high priority area. In 2006, basically, myself and my other colleagues, we went to South Korea as part of a know-how transfer program in which we worked closely with our Korean partners to build DubaiSat-1, which was an Earth observation mission. The mission was to build a 2.5-meter resolution spacecraft with significant Emirati contribution on the job training, but also building parts of it and delivering the spacecraft in basically 2 years. And launching it in less than 3 years. That was basically the goals that His Highness put for us. But it was a learning process. Something we had to explore. We knew that we're going to go into there and there's a lot of things that we're going to be learning. We're going to be making a lot of mistakes, but also mistakes that we learn from and further develop our skills from.
So how much infrastructure was already present for you to build on from that?
In the UAE, none. That's why we moved to South Korea. A team was based there. Me personally, I was based in South Korea for 7 years, working on DubaiSat-1 and DubaiSat-2. So DubaiSat-1 was launched in 2009 successfully. And it was based on a platform that was been previously built, the RazaqSat. It's a Malaysian spacecraft that the South Korean company built for them. However, one unique thing about the relationship that we had between us and the South Korean partners is that the know-how transfer was up to source code, subsystem level, component level. It was not just system level. So actually, we went deep into everything with them, schematics, source codes, different aspects of design, detailed design documents, peer reviews, and all that. Our contribution in DubaiSat-1 was about 30%, and it was more of a sort of guided and supervised work. Before we completed DubaiSat-2, His Highness asked us to think about the next project, and he gave us a new set of requirements for that. And basically he said, it has to be something more advanced than DubaiSat-1. The contribution has to be much more than what he did in DubaiSat-1. It has to be it needs to be more of a partnership in which you deliver certain parts and your South Korean partners deliver certain parts, because there's a lot to learn, so it was impossible for us to build everything from A to Z on our own. Still there's a lot to learn.
Right.
And the infrastructure was still being built here. We're testing. We need to understand what's needed. So it was a learning process. And it has to be something unique. So DubaiSat-2, actually, the whole spacecraft was developed from scratch. A totally new platform, very different than DubaiSat-1, in which the team has worked on different critical components, subsystems, and even system-level aspects of the mission. And our contribution was about 50%. In which it was more of a joint development rather than, being part of just a know-how transfer program. It was beyond that. The spacecraft, its imaging capacity or capability was higher. It was 1 meter resolution, which is considered very high for its category, because it was supposed to be less than 300 kilograms, which is quite small for an Earth observation mission. The data rate was much higher to download the images. The onboard memory storage capabilities were higher. We had different advanced functions, not just imaging, as in strip imaging. It was multi-strip imaging and stereotype imaging, which is considered something new for us. So it was a new challenge in which we had to build the spacecraft. And this happened also in South Korea because it was more of about a continuation of a program rather than just moving to Dubai and trying to build something on our own. So it was more of a stepped or phased approach, which made a lot of sense at that point. It didn't make sense for us to build all the facilities in Dubai and there's a big financial commitment when it comes to that, and use it once every 3-4 years. So that's why I was based in South Korea for 7 years. And DubaiSat-2 was successfully launched in November 2013, which marked a very significant and important milestone for the space program in the UAE. Before DubaiSat-1 and DubaiSat-2, the UAE was an excellent user of space technologies and also an excellent operator. So before the 90s, we used to use a lot of the satellite services. In the 90s, the Thuraya satellite was launched, and that marked an important milestone in our space program, in the UAE space program, in which we shifted from being just space services users to become space asset operators. 2009 was when we actually shifted by the successful launch of DubaiSat-1 from being just operators and users to actually manufacturers. However, with partners. So after the launch of DubaiSat-2 in 2013, His Highness announced the KhalifaSat project, which is supposed to be fully developed in the UAE. So that was a new requirement from him. It was like the first 2 spacecrafts, you worked on them, you spent long time in South Korea. Now is the time for us to move and shift the team here and have the activities taking place in the UAE. And KhalifaSat basically was the first spacecraft to be fully developed in the country. However, at that same time also, he asked us to look at something else. After the launch of DubaiSat-2 in end of 2013, he sat with us and he gave us a set of requirements that also presented another set of challenges that takes us way out of our comfort zone. He came to us and he said, I want us to celebrate the UAE's 50th anniversary with a very, very big achievement. And that I would like it to be by making UAE reach Mars, sending a mission to Mars. And the reasons why he wanted that is because he wanted to send a very strong message to the Arab youth. Is that if a country like the UAE is able to reach Mars in less than 50 years, you can do much more. A region that has long history when it comes to generating knowledge. More than 800 years ago, we used to generate knowledge. A lot of the scientists came out of this area. A lot of the knowledge that the scientists currently use and the technologies we use on a daily basis came out of the region. More than 800 years ago, this region was a symbol of tolerance. People of different backgrounds, different faith, lived together, built the region together, and also generated knowledge. So it was more about serving humanity. So it was a time of tolerance. So that's another message His Highness wants to send. As in, like, let's put all our differences aside and let's build the region. Let's get out of where we are. At that time, also, the region was going through a really tough time, and it still is, in which you have the Arab youth and a region with more than 100 million youth in it. It's a lot of potential. We're either investing their skills, innovative skills, in the wrong way by joining the wrong groups, or we're just migrating out of the region and you're losing all these skills, so the region stays the way it is. So this is a very strong message, not just to the Arab youth, but also to different countries in the region, to focus on the bigger picture. And what he told us also is like, the science has to be unique. It shouldn't be something that's been done before. On top of that, you need to build it, not buy it. So, and he's like, learn from others. The same way you learn from others in DubaiSat-1, DubaiSat-2, and now you reached KhalifaSat. Learn from others when it comes to building a mission to Mars. So don't start from scratch. Start from where others ended. And this is why we have partners. And we're working with the University of Colorado, Boulder, and also Arizona State University, and also University of California, Berkeley, on different aspects of the mission to build capacity in areas that we don't have capacity in. And one nice, unique thing also about outer space exploration missions is that, international collaboration is the core to every single aspect of it. And another thing His Highness told us that you do not have NASA's budget. You have very limited budget. You need to come up with an Emirati approach of developing such missions. So it's not just about being unique when it comes to science, but it's also about being unique in the way you run these programs. It has to be efficient, it has to be effective. And he gave us a very limited budget, which will be announced at the right time. Basically, that's why the model was about utilizing what exists, as long as the know-how and the knowledge comes back to the UAE or gets generated in the UAE. And that was basically end of 2013. And he asked us, he gave us 3 months. He said, come back to me with a plan of how you can do that. We got back to him. We gave him some ideas of how to conduct such a mission. And in July 2014, His Highness Sheikh Khalifa bin Zayed and His Highness Sheikh Mohammed bin Rashid announced that the UAE is going to be sending a mission to Mars before the 2nd of December 2021. And basically, that was a very important decision. That's basically, it's the first mission that's going to be going to Arab and Islamic mission that's going to be going to Mars. And with the duration that we had to conduct the mission is significantly less than other nations. Usually missions like this are developed in 10 to 12 years. At that time, basically 2014, we only had 6 years to deliver the mission. Why 6 years? Because the opportunity to launch to Mars comes once every 2 years. So the mission was announced in 2014. So we either launch in 2014, which is impossible. 2016, which is still impossible if you're going to build the mission, even if you're going to buy it. 2018, if you're going to build the mission on your own from scratch, I mean with partners obviously, but you still cannot deliver a mission. If you buy it, yes, maybe 2018. So the only thing, the earliest possible delivery was 2022, and it's one of the requirements that was set by the government. So we need to reach to Mars before the 2nd, or we need to reach Mars before the 2nd of December 2021. So that's why the mission currently, it's the way it was developed and the methodology that was taken in developing the mission, designing the mission, managing the mission has been unique and different than other missions. I'm happy to say that the mission is on track, and we are marching towards that deadline. The plan is to launch in summer 2020. We are very close to that. And the cruising phase will be 7 months to cruise from Earth to the red planet. We'll be traveling at a speed of 128,000 kilometers per hour during those 7 months, in which we will have to be conducting very sensitive maneuvers to make sure that the spacecraft is moving on the right trajectory, so we don't miss Mars or crash into Mars. And then basically, in the first quarter of 2021, the plan is to reach Mars, in which we'll have to slow down the spacecraft at that very specific time. We're going to have to be firing our thrusters for 30 minutes non-stop and take down the speed to almost 18,000 kilometers per hour. You go too slow, you crash into Mars. You go too fast, you skip Mars.
Right.
So that's another thing that within this mission. So there's a lot of challenges in developing the mission and designing the mission and developing mission from scratch, basically. An Emirati platform, basically. Yeah. But then you have the challenge of launch, which is risky. But then after launch, it's not over yet.
It's the landing.
No, it's not the landing. It's going to be an orbiter, because Emirates Mars Mission is going to orbit Mars.
Oh, so you're not landing on Mars?
No, it's an orbiter. Yeah.
Right.
So it's going to be orbiting Mars, and then you have those 30 minutes, which we call the MOI phase, the Mars Orbit Insertion phase.
Okay.
Which is very critical, very, very critical. And the problem is that there's 15 to 20 minutes delay in communication between you and the spacecraft around Mars. So everything has to happen autonomously. Whatever you send, the spacecraft is going to be getting it 15 or 20 minutes later.
20 minutes? That's it?
Yes, and whatever the spacecraft, that's a lot actually. Because most of the spacecraft that we have, it's almost real time.
Yeah.
And whatever happens around Mars, basically, if in MOI, you'll find basically 20 minutes later if it was successful or not.
Yeah, I mean, considering the distance.
So and basically, the Emirates Mars Mission is going to be an orbiter.
Yeah,
and it's going to be studying the Martian atmosphere. So the unique thing about the Emirates Mars Mission, what makes it stands out compared to other missions, is that it's for the first time, the scientific community around the world will be receiving a holistic view of the Martian atmosphere at different times of the day, at different seasons. Mars has 4 seasons, just like Earth. 1 day on Mars is equivalent to 24 hours and almost 38 minutes. There has been many different missions that studied the Martian atmosphere. However, at specific time, at specific season. We'll be studying the escape rate of hydrogen and oxygen and the relationship between the lower layer and the upper layer of the Martian atmosphere, which will help us in better understanding why Mars is losing its atmosphere. Why did it turn into a dead planet? Because one of the reasons that scientists believe it's a dead planet is because it's losing its atmosphere. Scientists believe that also more than 4 billion years ago, Mars might have been similar to Earth. It had similar geography and things like this, but it turned into a dead planet. So this is one of the reasons why humanity is trying to understand Mars. That's why we study Mars.
Yeah, it's a really important
Yes.
question to address.
And if we better understand Mars, it will definitely help us better understand Earth, better understand the changes happens in our universe, and so on. So there's a lot of benefits. And there's another requirement that His Highness put for us also at the beginning of the mission.
Yeah, what's that?
He said, I want this mission to be a catalyst to encourage young Emiratis to go into sciences. The country has invested a lot in building capacity and capability and even creating a career path for engineers. And then through DubaiSat 1 and DubaiSat 2 and KhalifaSat, we're able to actually make those engineers go into deeper level of technical development. However, the scientists had very limited career path. They either worked in schools as teachers or in very few labs, government-owned labs around the country, but not much of a career path. He's like, I want this mission to create a very clear career path for scientists and inspire the Emirati youth to go into sciences. Why? Because scientists are the ones who come up with new knowledge, with new discoveries, and the engineers are the ones who take this new knowledge and convert it into new technology. They complement each other, science and technology. And to have an innovative and creative and sustainable knowledge-based economy, you have to have a strong science and technology sector. And you need to have local activities here to address the different national challenges you have, and also leverage on certain economical opportunities that comes out of such activities.
Right.
So the UAE space program, and one of the things that His Highness Sheikh Khalifa bin Zayed and even His Highness Sheikh Mohammed bin Rashid and His Highness Sheikh Mohammed bin Zayed always emphasize is that the space program here in the UAE is not about reaching Mars. It's not about building spacecrafts only. It's about addressing big national challenges that we have. Food security, water security, energy resources, economic opportunities. We live in a tough region. Geographically, it's a tough region.
Right.
We live also in a region that has, politically, there's a lot of instability around us. So, through the Mars mission, Their Highnesses wanted, and the UAE government wanted to inspire the Emirati youth and the Arab youth to start seriously looking into these areas of science and technology. And one nice thing also about especially scientific missions like the Emirates Mars Mission, in these missions you cannot develop it without collaborating and working with different nations, with international partners, and without having an honest and transparent peer review process. If you want to learn from others and build on where others ended and avoid the mistakes that happened before, you need to have some kind of a peer review process. So in the Emirates Mars Mission, we have held more than 100 peer review meetings in which we got experts from different parts of the world, different backgrounds, who've worked on different missions, to come and review our designs and give us their
strongest
honest, unfiltered,
criticisms. Yeah.
Exactly. So it encourages the culture of transparency, the culture of collaboration, the culture of, sometimes we go with what they say, but sometimes, because people have different approaches to things, and everyone tells a different thing, but it's more about creating that kind of culture of openness, of having a dialogue between people of different perspectives, and delivering a mission, and basically putting the UAE's name around Mars. So this is another thing that's one nice message about such missions.
Right.
Also, and it helps in creating that culture.
Okay, so you mentioned this as an orbiter,
Yes.
as opposed to a lander or a rover. Can you kind of give us an idea about what these are and how an orbiter is different and why you were focusing on developing an orbiter specifically?
Okay, so this is a very good question. Actually, we always get asked this question because usually nations first go to the moon, explore the moon, send an orbiter first, and then land on the moon, and then send another mission to Mars, just a flyby, which doesn't even orbit. It just passes by, take a few images, and send it back, and that's it. And then they do an orbiter, and then they do a lander. In the UAE, we like to do things differently. We like to be efficient. We like to be effective. And we like big impact and big positive impact.
Okay.
So that's why we skipped the moon and went directly to Mars. However,
I see.
we have to do things in a measured way also.
Okay.
So landing on Mars is a bigger challenge, is a riskier. Having an orbiter around Mars is a big challenge by itself. There's a lot to be learned. So it was more about a measured risk that we took, in which there's a lot we need to learn first before we start landing. Having a flyby also is difficult, but an orbiter introduces a new set of challenges in which you can have more data, in which you can actually fuel your science community in the UAE with this data for many, many, many years and share it with the rest of the world.
Mm-hmm.
So there is differences. Basically, missions when it comes to outer space exploration, they're missions that are flybys, as I mentioned. They just fly by a moon or by a specific planet, gather data briefly and send it back, and that's it. And the mission is over. And it's usually a good way to get some initial understanding of that planet you're exploring. And it's usually a way to do things sometimes cheaper, but not always. Mm-hmm. The orbiter is usually you have to be captured around that planet, or you need to find a way for you to stay around, let's say, that moon. So that introduces a new set of challenges for that. But then the last thing about that, you continuously get data over the mission lifetime, which is usually 2 years, 3 years, 4 years. It depends on the mission. Then the lander, that's another thing, is usually you have an orbiter that delivers the lander around the specific planet that you are actually trying to study. And that lander actually gets released from the orbiter at a very specific time, and then it enters the planet that you're trying to study, and it lands in a specific site. And this whole entry, landing, descending and landing is as a process, very complicated. And it brings different sets of challenges. So usually some nations, what they do is they either have a lander as part of an orbiter, so they send the lander and they still have the orbiter, so they have 2 missions, one is an orbiter and one is a lander. Some, because of budget restrictions, because of the risks, they just have a temporary orbiter that orbits and then releases the lander, and then that's it. The orbiter goes away. It's a case by case. At the end of the day, it all comes to what you want to achieve as a science.
Yeah, right.
How much risk you want to take.
Yeah.
And how much budget you have.
Yeah.
These things play a big role in such missions.
I see, right. And Mars, because of the proximity, right?
Yes, but also these other reasons, as I mentioned, is that because Mars, scientists believe that more than 4 billion years ago might have been similar to Earth.
But isn't this applicable to other planets? I mean, other planets don't seem to be very habitable.
So from what we know now is basically, we think that Mars might have been similar to us. Others, I think there's more work needs to be done.
Yeah, right. So there's a lot more diversity on other planets.
And there's a lot of unanswered questions. There's a lot of planets that we need to further study, further understand.
Wow. God, that's fascinating to think that, it must have been, habitable a couple billion years ago. That's an absolutely fascinating idea. And going back to this data that we are going to be gathering from Mars, what are some of the questions that we hope to address? Maybe something a little bit more specific, some of the questions that we hope to address and how they would inform life on Earth, right? So maybe from the perspective of a scientist, but also I guess from the perspective of somebody in public.
Public, yes. No, that's a very good question. At the end of the day, I mean, the reason why we explore other planets and we have outer space exploration missions is for us to preserve our planet. Protect our planet.
Right. Okay. It's usually the opposite of what people think, right? Because people think, we're leaving, we're going away, we're just kind of calling it quits on this planet.
No, that's
it's the opposite. It's about preserving this planet.
Exactly. So we go there. If you develop a technology that works around Mars, if you're able to put a human on Mars and make him live in such a toxic environment and have him eat, drink, sleep, and then you bring him back here, then definitely this technology, you can utilize it on Earth in different areas. We're talking about a dead planet, if we talk about Mars. Mm-hmm. No resources whatsoever. And you're able to plant something there, you're able to have water there, then the areas around our planet that has issues with water resources and food resources can definitely leverage on these technologies.
Right.
And the models that you develop to understand, for example, the escape rates of hydrogen and oxygen, and the escape, or the way that Mars is losing its atmosphere, all these things, these models could be like the knowledge it generates in developing these models could be used to develop models about Earth.
Yeah,
and understand better Earth.
Yeah.
So there's a lot of environmental issues that you can address by understanding other planets.
Yeah, so the adaptability of the technology on Mars informs the technology here.
Yes.
Which is substantially less extreme.
Yes. And the thing is also one nice thing about space exploration is that the environment that you expose the technology to is an extremely harsh environment.
Yeah, I understand.
Very harsh environment. So the engineering, the quality of the engineering and the science work that has to go through into it is extremely advanced. So it's usually, if you, as a nation, you're able to deliver products that work in space, that basically sets the standard for your industry. That's also considered like a strong branding point for you as a nation, that your industry is capable to deliver something that's space quality. Space quality. Mm-hmm. And usually space quality or space standard is considered the highest standard when it comes to technology developed. If you develop a technology that works in the desert, that doesn't mean it's going to work in the North Pole, in a cold, very extreme cold environment. If you develop a technology that works in the air, doesn't mean it's going to work underneath the water.
Was actually a question I had while you were saying this.
But when it comes to space, whatever you develop gets exposed to all extremes. It gets exposed to minus 125 degrees Celsius all the way up to sometimes plus 70 degrees Celsius or something like this. Mm-hmm. It really depends on the mission also, where we're going, what you're exploring. But that technology itself, if you talk about the spacecraft that orbits Earth, it will go to both extremes because it orbits Earth, it goes to the cold side and it goes to the warm sides and all that, and there's no atmosphere to protect it, and there's radiation and all that gets exposed to it. Mm-hmm. So technically speaking, technology that works in space should work in all different environments that we have on Earth. Mm-hmm. So it's a very good way to qualify your technology and make it in a way that's adaptable and applicable in multiple kind of setups and different environments on Earth. Mm-hmm. So you achieve a lot of, you hit a lot of birds with one stone, basically.
And we'll still have Internet Explorer.
Yep. So,
right. So can you tell us about the design and the testing process of the Emirates Mars Mission? So what are the main systems that make up this spacecraft?
So like any spacecraft, you need to have the command and data handling subsystem, which is in charge of commanding. It's basically the brains of the spacecraft. It consists of hardware and software. It usually has the power subsystem, which is responsible for generating power and distributing the power to the different subsystems and components of a spacecraft. You have the science instruments. In Emirates Mars Mission, we have 3 science instruments. The imager, the EXI, which is basically a visible imager. We have the ultraviolet spectrograph, which is called EMUs. And we have even the infrared spectrometer, the emirs. All work together to gather data. Spacecrafts usually have telecommunication subsystems to be able to communicate with the spacecraft. You have the mechanical structure, which houses the spacecraft. So these are the major sort of components of any spacecraft. It's designed in a different way as per the requirements and the needs of a mission. Mm-hmm, Earth orbiting missions are different than geostationary missions are different than outer space exploration and so on. Yeah. But these are the basic components that you need to have.
Yeah, I understand. Yeah.
And then you have to have thermal control subsystem and things like this also.
Right. So how large? How large is this spacecraft?
Emirates Mars Mission is going to be about 1.5 tons.
Okay.
It's going to be about 3.5 meters in height with the solar panel deployed around 8 meters.
Yeah.
It's a very big system. It's one of the biggest that we built at the Mohammed Space Center.
Yeah.
And so basically the way we start is first you start with setting the mission requirements, in which you identify your missions. But before that, there's a very important step in outer space exploration. You need to identify your science questions. So the way that we did it, because it was the first time we basically build a mission to Mars, we went to a group called the MEPAC group, in which basically it's a group of scientists from around the world who come up with different science questions about Mars, in which nations usually refer to them to select which question they want to answer. Because there's no country around the world wants to do or replicate what others did when it comes to science, answering science questions. You always want to bring something new.
Yeah, bridging the gaps.
Exactly. And it helps in coordinating, so you don't do something that others are doing. So we worked with them in identifying those science questions that I mentioned earlier. And based on that, we came up with the mission requirements. From the mission requirements, then we break it down into system level requirements, either ground segment or space segment, and even launch segment. And then from there, we take it down to subsystem. And also, while doing that, we also come up with a system architecture. We design the system, how it's going to look like, what it's going to consist of, and so on. And then we go into the detailed design of each subsystem component when it comes to the schematics, when it comes to the software, when it comes to the ICDs, the interface documents, when it comes to the analysis that we need to do. So there's a big analysis process. So if you talk about the power system, you need to do the power analysis. If you talk about the telecommunication subsystem, you have to do the link budget and things like this. When it comes to the attitude control, you need to come up with a certain set of analysis that tells you what is required from your attitude control system to be able to deliver the mission. All that comes together and gets peer-reviewed. And this process usually takes about, depends on the mission, but in our case, we didn't have much of a time. So it took us about 2 years to complete this process of analyzing, designing, setting requirements, and having it heavily peer-reviewed. So it was more than 2 years, and then you go into manufacturing, in which you manufacture each subsystem. Some things you do in-house, some things you outsource. It just depends on the priorities, because it's impossible for you to build everything from A to Z on your own. There's no single mission around the world that builds subsystems and components of its spacecraft from A to Z in-house. That doesn't happen.
There's probably no object around the world today.
Exactly. So there's critical components that you need to build. There's important. These are the things you focus on. It's like building a car. When you build a car, and usually the company that builds a car, they design and build the engine, they design the chassis and the body. But then when it comes to, let's say, the sound system or the wheels, these things are usually you subcontract to others.
Yeah,
right. Same thing when it comes to spacecraft development. So that also took about a year and a half to 2 years also. I would say 2 years. It depends on the subsystem that we were developing. Some subsystems, for example, the propulsion subsystem, which is the thruster that takes us from Earth to Mars, takes a long time for us to develop certain components. So it requires, basically, it's a long lead item that takes at least some components more than a year to be delivered. Same thing with the telecommunication subsystem. Some parts take more than a year and a half to be delivered. After that, we started basically, once those were done, we tested each subsystem by itself, and we did basically environmental testing to each subsystem by itself, in which we exposed them to, we conduct basically a thermal vacuum test to them. We do vibration tests to these subsystems and instruments. And if they qualify and they're ready, and if there's any issues, we have to fix it, then we bring them all together, which happened, and we assemble them as part of what we call the observatory. Mm-hmm. And we have completed that process successfully. And as we speak today, we are conducting our final environmental testing at the observatory level, like the whole spacecraft. So we did, for the whole spacecraft, vibration test, we did acoustic test, we did EMI, EMC test, we did shock test, and now we're doing the thermal vacuum test, in which we take it to very, very low temperatures, down to minus 25 to 30 degrees Celsius, and then we take it up to plus 55, plus 60 degrees Celsius. Different cycles we do it, and we run it as if it's going through the mission. So we have scenarios generated in which basically, okay, this is the launch phase, and we do the testing for the launch phase. Yeah. And then we do the cruise phase. We do the similar testing, the cold soak and the hot soak test for the cruise phase. And then we do it for MOI, the Mars orbit insertion. Then we do it for the capture orbit when we first reach Mars. Then we do it for the science orbit. So it's a long process. And we had to conduct this kind of testing in specialized facilities. And this is one unique thing about the mission, is that we didn't just rely on our facilities. We went around the world. Whatever is more efficient and more effective when it comes to budget and to
design and
schedule.
Okay,
the schedule. So we went with that approach.
Right. Okay.
And this is what makes this mission very unique. Because usually nations, they do things, they try to do it as much as possible in just one location, which is good. But then it introduces sometimes
a lot of difficulties. Yeah.
When it comes to cost and things like this.
Yeah, I understand.
Yeah. And UAE's government vision was basically the most important thing for us is the knowledge, the design work, the knowledge. This is what we care about. Knowledge coming back into the UAE, knowledge being generated in the UAE, this is what we care about. And being smart and efficient about how we do things. Which is, I think, it sets a new trend, which a lot of entities have shown interest in how we are conducting such missions and are very curious to see how the mission has been developed.
I see. Right. And it really sounds like a lot of this work is being conducted by engineers and
scientists.
Engineers. What kind of scientists? So do you have maybe biologists on board or biochemists on board?
It's a combination of things, but then this is something that we in the UAE are trying to do actually, and this is one thing about the mission, is that to create an impact, because we had difficulties in having students going into the sciences. So a lot of universities in the country didn't actually offer science degrees, good universities, but they were focused only on engineering. So after the announcement of the mission, actually, a number of universities started new programs or departments in their entities for sciences, either math, physics, or chemistry. Students who were studying international relations switched to math and physics. Students who were studying finance switched to math and physics and chemistry, some biology. It's still work in progress, but we're seeing the effect of that. As scientists, we always work with everyone. So we have a team of young Emiratis who've studied science or are going into sciences, and we're working with them. But then again, to be a scientist, it's a process. It's a long process. You cannot be called a scientist by just getting a degree in a specific field. There's a lot of work needs to be done. You have to spend at least 10 to 15 years doing R&D, generating papers, having thesis and dissertation in specific areas related to science to be officially called a scientist. So you have people who study sciences, but then we want them to reach that, and that's still work in progress. And so as a team, as I said, so we have people from different backgrounds working together. The one thing about space missions, especially like in a mission like the Emirates Mars Mission, one thing is Our Highness always emphasized is that this mission is not about space. It's not about the Mohammed Space Center. It's not about the space sector in the UAE. It's a national project. It's a national project that's supposed to impact all different sectors in the UAE. The space sector, the academic sector, the industrial sector, and all these need to be impacted, and they are all part of this mission. This is what's unique about the Emirates Mars Mission. And this is why His Highness called it also hope, the hope mission, Misbar al-Amal, for a reason. It's a hope for the youth of the region, but also a hope for the youth of the UAE, thinking about the future and making that big impact in all different sectors. And to deliver a mission like this, you cannot just do it with scientists and engineers. You need to have the lawyers. You need to have the people who worked in human resources, who worked in finance, who worked in project management. All of them come together and work together to deliver a mission. Mm-hmm. So in Emirates Mars Mission, the majority of the team members that we have are engineers and scientists. However, there's also a good big part of people who are core members of the mission with background either in law or in finance or in management and so on. Because at the end of the day, you need to manage a team. At the end of the day, you need to manage a budget. You need to manage a schedule. You need to negotiate a contract. You need to negotiate an agreement with different nations. You need to have people with policy background working in the mission. So it's inclusive of all different backgrounds. And to be part of UAE space program in general, I always tell people, do what you like. Do what you actually
like want to specialize in, and we can relate it to space.
Exactly.
Right?
What the areas that interest you the most.
Yeah.
But that doesn't mean if you go there you cannot work in the space sector. No.
Yeah.
It is different opportunities in the space sector.
You got any psychologists in the space sector?
Definitely.
Should I be thinking of switching?
Maybe you should. Maybe you should.
So, If you could choose another, this is just out of curiosity, I want to ask you, if you could choose another planet for humans to explore, maybe if there's a planet that's kind of teasing you in the background, what would it be?
It's a very difficult question. I think we need to explore all planets that we have in our universe or in our solar system.
In our solar system first.
So we need to explore first. Let me rephrase that. Sorry. I think we need.
Right.
So I think we really need to explore all the planets we have in our solar system first, because there's a lot of understanding. Each planet presents different sets of challenges and different sets of environment that you get to study that planet, and new set of knowledge that brings to us that will definitely either directly or indirectly or even sooner or later will benefit us in better understanding our planet. It's a very difficult question. I cannot tell you which planet we should. I think we should explore them all. Whatever we can explore, let us explore it. But smartly and efficiently.
Okay.
And effectively.
Right. All right. On that note, I think we'll conclude our episode. Thank you so much for coming on the show. And I really look forward to hearing more news about the mission in the future.
Thank you very much for having me.
That was Omran Sharaf, Project Director of the Emirates Mission to Mars. This episode was sponsored by Mutant Academy. To listen to more episodes, you can find Good Question on Apple Podcasts, Stitcher, Spotify, or wherever you get your podcasts. If you have any questions, comments, or suggestions for what you'd like to see from us next, you can reach us at GoodQuestionUAE on Instagram and Twitter, or email us at info@goodquestion.ae. Good Question is a production of the Youth Science Council and the Office of Advanced Sciences in the United Arab Emirates. Produced and directed by Hind Al Ali and Hayat Al Hassan. Sound design by Jean-Michel Elias. Sara Al Ali is our editor. Our social media and communications are managed by Mohammed and Mansouri and Fatma Luta. And I'm Sada Shirbaji.